This video will talk about solving compound inequalities. If you have two simple inequalities, just like this, and then you connect them with either or and, you call this inequality a compound inequality. So a compound inequality is just a type of inequality that connects two simple inequalities. The connectors can be or and. Alright, so our first example will be this kind of compound inequalities that makes use of the connector or. Okay, so to solve this kind of inequality, all we have to do is we just solve each simple inequality following the steps in solving simple inequalities. Okay, so first we focus on this part of the inequality, this simple inequality. Right, so here, remember the three steps. First is to do distribution. If you have parentheses, that's step one, but we don't have parentheses, so we just skip that. And then we go to step two is in step two, we move the variables to the left and constants to the right. So here, I have this variable. I should move it to the left, and from a negative 5x, it will become a positive 5x. All right, and that's my only variable, so I'll just bring down the symbol here. Negative 6 is a constant, and it should stay in this side. So I'll use the same sign, but negative 36 is coming from the left. If I move it to the right, it will become a positive 36. So that's step 2, transpose the variable to the left and to the right. And now we simplify each side. So we have, this is 5x is less than negative 36 plus 6 is 30. And then that's step 2. Step 3 is to undo division or multiplication. So we have here, we need to divide by 5 by 5. So this is crossed out. Our x now is less than 30 divided by 5 is a positive 6. All right. So we've solved the first inequality. And because this is compound, we have another inequality over here, and we still follow the steps. So we don't need to do the parentheses because there's no parentheses. We just need to move the variable to the left and constants to the right. My variable here is already in the left side, so I'll just bring it down. Negative 5x. And then that's my only variable, so less than. Negative 46 will remain here. And then negative 6 will be moved to the right side, so I should make that into a positive 6. Okay, and now we simplify each side. Negative 46 plus 6 is negative 40. So this is negative 5x less than negative 40. Okay, and then we now divide by negative 5, divide by negative 5. Now since I divided by a negative number here, remember that special rule, if you divide by the negative number, your inequality will turn into opposite direction. Okay, so you have here x is greater than negative 40 by negative 5 is positive 8. Now, after solving the two inequalities, don't forget that your answers must be connected by the same connector, which is OR. Okay, OR. So that's our answer. Again, you just need to solve each of the simple inequalities individually, following the steps, and then your final answer should have a connector OR at the end. Okay, now if we will show the graph of this inequality, so we're looking at positive 6. Let's say this is positive 6, this is positive 8, 6 and 8. At 6, at positive 6, it's an open circle to the left. Okay, and then for this part, it's an open circle at 8 to the right. So that's the graph of this inequality. And the rule for OR is just the union of the graph. So these two graphs will just be joined together. So that will be the final graph. Our next example is this kind of inequality, a compound inequality that makes use of the connector and. Okay, so same with OR, we just solve each of these simple inequality following the steps that we have. So let's focus here. Okay, let's focus here. So there's no parentheses, so no need to do the distribution. Step 2 will have the variable to the left side. So I will move this negative 3x to the left, and it should become a positive 3x. All right, and that's my only variable. So I'll just bring down the inequality symbol. Constants must be here. Positive 8 is already in the right side, so I'll just bring it down. However, negative 7 must be moved to the left, to the right side. It's coming from the left. So from negative 7, I should make it to a positive 7. Okay, and then now 8 plus 7, that's 15. And then just bring down this 3x greater than or equal to 15. And then step 3 is to undo division. So we just divide by 3. All right. So that's crossed out. So you have x greater than or equal 15 divided by 3. That's actually a positive 5. Okay. After solving one of the simple inequalities, we now go to the other simple inequality because this is a compound. So here, I need my variable on the left side. So um, it's already in the left, so I'll just bring it down. And then the symbol, negative 19 is already in the right. and I want it to the right side, so stays the same. However, 8 must be moved to the right side. It's coming from the left, so positive 8 will become minus 8. All right, and then we simplify now each side. So this is negative 3x is greater than negative 19 minus 8. That's negative 27. Okay, and then step 3 is to undo multiplications by doing division. So we just divide. Because we used a negative number here, again, there is a need to flip the inequality. Take into that special rule. So you have x is less than negative 27 by negative 3. That's a positive 9. Now, because this is compound inequality, we have to put a connector in between. Our connector this time is AND. Right? Now, for AND, there is some additional things that you need to do. Okay? All right. Now, for this kind of inequality, the AND inequality, compound inequality, we can make this two inequality, like we can join together these two inequalities. Okay. How to do it? Here's how you do it. Okay. We just need to make sure that in here, the middle number here, the numbers that you have here, will have the excess. Okay. So for this part, I should have my x in here, and then for this part, I should have my x in here. So x must be both found in this side. Now, the only problem is for this inequality because my x is on this side. So what you can do is you can flip everything. Okay, you can switch the numbers. If you switch the two numbers, you also need to switch the inequality. So x greater than 5, switch the two things. So 5 here and x in here. However, you need to switch also this inequality. All right. And now I'll just bring down x less than 9. So that's what I'm saying. I should have excess in here. And then once you have the excess in this side, you can now rewrite this into a single x and then bring down less than or equal to 5 for this side and then less than 9. If you're familiar, this is actually the segment format. Okay, so for AND, you just need to do some additional thing. You just need to join together these two inequalities into this format. So in the delta math, this is the answer that's being accepted. Okay, sometimes you can do this for AND, sometimes not. But for this video, we're doing this kind of inequality. Now to graph this inequality, so we just make the number line here. So we're looking at 5 and 9. So let's say this is number 5, this is number 9. So this is closed at 5, and then open circle at 9, and then we just connect them. That's the graph. All right, now let's take a look at our last example for this video. So the last example is actually a compound inequality in this format. We call it the segment format. So as you can see in here, I don't have the or AND, but I have 3 sides and I have 2 inequalities. This is actually the same with the AND inequality. But we'll just solve it this in this format. So here you have your left side. This is your left side. You have the middle part and then the right side. Okay, left, middle, and right side. All right, so your goal in here is to make sure in the middle part, you only want x in here. All right, so that means we need to remove whatever numbers is in here. So like negative 3, this negative 3 here, we need to remove it, and then this another negative 3. Now, so I will begin by removing negative 3 in here, doing the opposite. It's negative 3, the opposite is a positive 3. So I'll do plus 3. Whatever you do in the middle part, you have to do it to the left and to the right. Okay, to all sides. So now we put this line in here. So this will become what? On the left side, you have negative 9 plus 3, that's negative 6. And then bring down the symbol. And then this will be crossed out. So you have negative 3x here in the middle part. And then another symbol. And then negative 24 plus 3 is negative 21. Okay. Again, your goal is you only want x in the middle part. So I need to remove negative 3 and I have my multiplication. So to undo a multiplication, I'll just divide by negative 3. Okay. And if you do it in the middle part, you have to do it also to the left and to the right side. Okay. Now notice that you divided by a negative. Remember the rule, if you divided by a negative number, you have to flip the inequalities. Okay, that rule still applies in here. So let's now simplify. Negative 6 divided by negative 3 is a positive 2. That's a positive 2. Okay, and we need to flip the inequality. And then this will be crossed out. So you have x in the middle part. And then this will be flipped again because we used a negative number. Negative 21 by negative 3 is a positive 7. So now I only have my x in the middle part, so this is already the answer. Okay. Now to graph this, you only need the numbers 2 and 7. Let's say this is 2, this is 7. At positive 2, it's a closed circle. At 7, it's an open circle. And then we just connect them.